Today we got an authentic 7 minute summary. I'm not going to talk for 15 minutes before and after the 7 minute summary because I got some things to do. I'm going to just crush only a 7 minute summary. Maybe I'll yap. Let's take a look at it. Today we're actually going to include the sections here in our 7 minute summary because I am not messing around. Let us start. Set a timer of 7 minutes.
All right. I created a
Looking good.
timer that will go off in 7 minutes.
Atomic spectra of gases, early models of the atom, Bohr's model of the hydrogen atom, the quantum model of the hydrogen atom, the wave functions for hydrogen, physical interpretations of quantum numbers, the exclusion principle and the periodic table, more on atomic spectra, visible and X-ray, spontaneous and stimulated transitions, lasers. That is a lot of stuff. In Chapter 41, we introduce some basic concepts and techniques used in quantum mechanics along with their applications to various one-dimensional systems. In this chapter, we apply quantum mechanics to atomic systems. A large portion of this chapter is focused on the application of quantum mechanics to the study of the hydrogen atom. Understanding the hydrogen atom, the simplest atomic system, is important for several reasons. The hydrogen atom is the only atomic system that can be solved exactly. Much of what is learned in the 20th century about the hydrogen atom with its single electron can be extended to such single electron ions as helium plus and lithium 2 plus. The hydrogen atom is an ideal system. Okay, we can't go through that, but a bunch of reasons why we use quantum mechanics. Atomic spectra, as pointed out in section 40. Okay, I'm not going to read all that. I'm just going to look at bold and italicized words. This is italicized. It says discrete. This is bold. It says line spectrum. Together it says discrete line spectrum. Over here I see another italicized word, continuous. Further down I see a bolded word, emission spectroscopy. Interesting. We also have absorption spectroscopy. If you don't know about spectroscopy, it appears 2 times here, and before it comes the word absorption and emission. So it might be interesting. Just Google search what is spectroscopy. Try to explain to yourself in a couple of minutes. So if you hear some squeaking, let's read this pitfall prevention. Buddy, relax. We got the 7 minute summary. The lines, why lines? The phrase spectral lines is often used when discussing radiation for atoms. Lines are seen because the light passes through a long, very narrow slit before being separated by wavelength. Okay. 4 minutes, 55 seconds. Let's zoom through. Here are the lines they're talking about. This is pretty interesting. I'm going to just tell you, this is like the fingerprint of a element. So we got the periodic table of elements. Over here in the top, we have hydrogen. Here we have Hg with, I think, is mercury. Here we have Ne, which I think is neon. And take a look at that other video I did about Wien's law. When you glow shit up, when you heat shit up, it starts to glow. This is a similar kind of thing. We got nanometers here, so wavelength, and we got these different colors and stuff, different lines. Think about that. Maybe Google search line spectra, stuff like this, and read this chapter a bit slowly to see what I'm talking about. But right now we just got the summary, 7 minute summary. We got the Balmer series. What does that mean? Interesting looking equation with the letters N, lambda, R, subscript H. We got the Rydberg constant. All right. I'm not going to look at that too much. Damn, we got more series. Lyman Paschen bracket series. Similar looking equations. Early models of the atom. Joseph John Thomson, the recipient of the Nobel Prize in Physics in 1906, Thomson is usually considered the discoverer of the electron. He opened up the field for subatomic particle physics with his extensive work on the deflection of cathode rays, electrons in an electric field. I think cathode rays are the first TV. I think that's what they used to first kind of like make black and white TVs back in the day. Sorry, my throat is a little rusty. I don't got no mint tea with me today. I got 3 minutes, 20 seconds. Let's zoom through this section. We got electrons are small negative charges at various locations. Okay, we got the plum pudding model, Thomson's model of the atom, the plum pudding model as I remember it when I first learned this. We got the classical model of nuclear atom predicts that the atom decays. This is one of the reasons why we need quantum mechanics to explain subatomic particles like this. We got some other interesting pictures here and Bohr's model of the hydrogen atom. I don't know if you guys are picking up as much as I am here. I'm not really picking up too much. I'm just looking very quickly through the chapter, looking at pictures. Physical components. Okay, take a look at this guy, Niels Bohr. Very cool dude. I'm not going to read his picture right now, but we got some equations. This looks like the equation for photoelectric effect. Not sure if that's the case. If you don't remember the photoelectric effect, no worries. We got another equation here. It looks like energy, Ku, stuff like this. More equations. Damn, this looks like a lot of equations. But let's look at these. These are probably the most important ones. We got this stuff here and this stuff here. This looks like energy. And then we got the Bohr radius and the radii of Bohr orbits in hydrogen. I'm not sure if any of this is important. It probably is because it's written kind of in yellow here. We got this cool looking graph and the things we've seen before. Lyman, Balmer, Paschen, and there was another one called Bracket series. Buddy, relax. We got 1 minute 48 seconds. Let's keep zooming through. Another interesting equation. I am not going to remember this. This looks super long and crazy. Yo, quit squeaking, bruh. Pitfall prevention. I don't think we have time to read that either. Bohr's correspondence principle. Quantum physics agrees with classical physics when the difference between quantized levels becomes vanishingly small. This is an interesting sentence. Maybe screenshot this and say it to your friends and family members. See what they think. Correspondence principle, again, in bold, we got an example. More examples. Let me check the timer. 1 minute, 10 seconds. The quantum model of the hydrogen atom. This is probably where we're getting our pants full and heavy. We got an interesting looking equation. This is what I was looking for. This is the Schrodinger equation in 3D, as you can see with the like little x, y, and z in the denominator over there. No need to worry about that too much. Here is how you solve it. It is actually a differential equation solved by separation of variables. Let me know if you want me to do a video about that. It is very cool, but you won't need to like solve too much stuff related to that in this chapter or in this course today. That's a bit more advanced. What you have to remember is kind of the concepts. Allowed energies of a quantum hydrogen atom. So this is energy. It says allowed energies. We have n equals 1, 2, 3, 4. This is a classic thing in quantum mechanics. The energy is quantized. What does that mean? I don't know. We got restrictions on the values of the hydrogen atom, quantum numbers. My timer is almost done. 15 seconds. Dude, the wave functions of hydrogen, ground state of hydrogen, example, physical interpretations of quantum numbers. The orbital, oh my, what is this? Yo, we ain't got time for this. I'm sorry, guys, we didn't finish this. Space quantization, let me zoom through the spin magnetic quantum numbers. Whoa, I literally got through half of that, I think. The exclusion principle, look at our boy Wolfgang, my boy Wolfgang Pauli. Oh my goodness, this looks like chemistry. This is a lot of stuff to learn when I can't even read that. It's not part of the 7-minute summary, and I promised I wouldn't yap any longer. Damn, we literally missed half of the section. More on atomic spectra, visible and X-ray. What is this graph, bro? Look at this. Another crazy graph. X-ray spectra. Estimating. How long is spontaneous? Okay, it ends with lasers after this. Here we go. Lasers. Little section on lasers. Applications of lasers. Oh my god. Okay. Listen, bro. You have to do this. Try it out. Even if you fail like I did, you got new information in your brain. We learned about cool things, the Balmer series. We learned about hydrogen. We learned about quantum mechanics being difficult. So yeah, thank you guys for watching Chapter 42, Atomic Physics. Try your own 7-minute summary. Sorry about the squeaking today. I will see you guys in the next video. Peace out.